Alright guys, we're going to do a general review of transformations just for those of you that need a refresher. Let's start with our transformation equation here. This is our transformation equation. And these A, K, D, and C values all do some different things. So let's take a look first at the A value. If the A value is negative, this causes a vertical flip, or a vertical reflection, you can call it as well. And if A is between 0 and 1, this is considered to be a vertical compression. Okay, and if A is greater than 1, this is a vertical stretch. Okay, now I'm not including the negative parts of these, so if something were, like, let's say, greater than 1 and also negative, so 2 and then it's also negative, the negative part is the vertical flip and the 2 part is the vertical stretch. Okay? So that is our A value. It's always going to be located at the front of the equation as a multiplication, and it will be outside the brackets with the x. Okay, let's move on to the K value here. Okay, the K value, and I should also mention that the A value is a change to the y coordinates. Okay, let's move on to the K value here. Okay, so if the K value is negative, you can probably guess that this is going to be a horizontal flip. Okay, and the K value is actually the exact opposite of what the A value does. So if our K value is between 0 and 1, so something like a half or a third, this is actually going to be a horizontal stretch. Okay, and if the K value is greater than 1, that will be a horizontal compression. Okay, so let's just continue on the next slide with our D and C values. Okay, the D value. The D value is kind of opposite of how it appears. Because of this little negative inside of our bracket here, the D value actually looks negative when it's positive, and it looks positive when it's negative. Okay, so what I mean is, if it appears positive in the equation, it's actually negative. Okay, because if I enter in a negative in here, we'll have a negative and negative, and it makes it positive. And this is going to move left. Okay? If it appears negative in your equation, it's actually positive, because if I plug a positive into that equation, it's going to look like a negative. This moves right. Okay? The C value is a little bit more straightforward, which is nice. The C value, if it's positive, it's going to shift your graph up, and if it's negative, it's going to shift your graph down. Okay? I forgot to mention on the last slide, our K value is a change to the x coordinates. Okay, our D value is also a change to the x coordinate. And our C value is a change to our y coordinates. Okay, what we end up getting when we do our transformations is essentially this. We're going to take the reciprocal of K, and then we'll switch the sign of whatever the D value is that we see in the equation. And then we'll have A times Y plus C when we do our transformations. And these come from points that we take from our parent function. Okay, it's also important to know that this guy right here, this F inside here, is actually not a transformation. It represents each individual parent function that we work with. Okay, so speaking of parent functions, we dealt with a couple different parent functions in this course. Specifically in the transformation unit, we dealt with x squared, root x, and 1 over x. Okay, and we decided that we choose our x's strategically for these. For x squared, we can basically choose any x that we want, but since the vertex of this is at 0, 0, we choose a couple x values to the left of that and a couple x values to the right of that. Okay, so what we decide to do is basically take -2, -1, 0, 1, and 2. And we can get the y values of these by basically just putting them into this equation. So we essentially are just squaring them to get the y's. So negative 2 squared is positive 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Okay, for root x, because I'm going to end up actually square rooting these things, what I want to do is choose x's that are perfect squares. So 0, 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, and those are usually enough points that we can get a good idea of what our function looks like. So 0 square rooted is 0, 1 square rooted is 1, 4 square rooted is 2, and root 9 is 3. Okay, now for these ones we choose a little bit more strategically. We choose negative 2, negative 1, negative 1 half. We can't choose 0 for this because 1 over 0 is undefined. Okay, we choose a half, 1, and 2. And when we plug these into our equation, we get negative 1 half, negative 1, negative 2, 2, 1, and a half. This guy also has asymptotes. Okay, remember we talked about those invisible lines along the x and y axes. So the line x equals 0 and y equals 0, these are actually undefined for this function. Okay, these are what the graphs of our parent functions look like. Okay, so let's take a look at one of our parent functions here. The first thing that I want to do is I'm going to use my transformation equation, the one on the first page, to identify the a, k, g, and c values. So here's an a k, a d, and a c. Okay, and remember that anything inside of the actual function, meaning the square root part, is a change to the x, and anything that is on the outside, which is the a and the c, those are changed to the y. So my parent function here, we're going to look at the main operation that this function performs, which is square rooting. So my parent function must be the square root of x. So here's the key points that we're going to start with from our last page here. Okay, and what we're going to do is we're going to perform the a, k, d, and c transformations on these. Okay, so remembering that we're going to do the reciprocal of k plus the d value. So our k value is 1/2, so the reciprocal of a half is 2. I'm going to do 2 times x, and I will do the opposite of the d value, so plus 1. And then we're going to do a times y plus c. So my a value is 2 times y, and then plus 4. Okay, we're going to take a second and calculate the x's and calculate the y's. Okay, so I've calculated my x's and y's. Now we're going to go and we're just going to graph the parent function and graph the transformed function. Alright, so I'm going to start by graphing the parent function. We're going to assume each of these ticks goes by 1. So we'll graph 0, 0, 1, 1, 4, 2, and 9, 3. Okay, so there's my parent, like so, and I'm going to label that root x. Okay, and then we're going to graph the transformed function. One, 4, 3, 6, 9, 8, and 19, 10. Okay, there's my points, and here's my graph. Okay, and that's our transformed function. One thing that I do like to remind people of is that the starting point of this parent function gets transformed to the starting point of this parent function, which is right here. And we need to make sure that this function specifically only goes off toward one end. So that's why I have the arrow on this end rather than on the other end. So you just want to pay attention to what the point 0, 0 gets transformed into here, because that will be your starting point for your second graph. Okay, that's all.